This is the screencast for section 6.1, example 3, vector operations. So we're going to say let u equal this vector u1 comma u2 and v equal the vector v1 comma v2. And they're vectors, and let k be a real number scalar. The sum of the two vectors, you can just add their x-coordinates and then add their y-coordinates and get the new vector. And then you can also multiply each of the x and y coordinates by that scalar. And visually, here's what's happening. If you're adding two vectors together, it's like taking one and then at the head of the first vector attaching the tail of the second, and then the result would be the final u plus v vector. We call that the tail to head representation for obvious reasons. The parallel representation, which I don't think visually is as easy to see what's happening, but basically if you have u and v both in standard form, the u plus v is going to be a parallelogram made from u plus v and then v plus u. So if I were to multiply a vector by, let's say, 2, it would make that vector twice as long. If I were going to multiply a vector by 1/2, it would make it half as long, or the magnitude would be cut in half. If I were to multiply by -2, that would flip the vector in the opposite direction, because then the vector would still start at the origin, but now its x and y values would be opposite, so the vector would be pointing the other way. Which leads us to vector subtraction. The vector u and then minus v, so unlike u plus v, v would be traveling in the opposite direction here. So now it's u and then minus v. So the head of u and the tail of v are still attached, but now v is pointing the other way. So u minus v is going to go this direction. Example 3 asks us for a couple of applications. So we're going to perform vector operations. We're going to let u equal -1 comma 3 and v equal 4 comma 7. Part A asks me to add those two vectors together. So numerically what's happening to u plus v is that -1 and 4 are getting added together, and then 3 and 7 are getting added together to make the resulting vector u plus v 3 comma 10. Visually what's happening is the vector u, which is -1 comma 3, is going to start out in standard representation, and then vector v is going to be attached to the head of vector u. So as you can see numerically, all I'm doing is adding the vector v's x-coordinate and y-coordinates respectively. So I'm going to change the position of vector v, but still use an equivalent vector that has the same magnitude and same direction. Just attach it onto the end of the u vector. So I'm going to add 4 to the x-coordinates of the u head of the u vector. 1, 2, 3, 4. And then I'm going to add 7 onto the y-coordinates of the head of the u vector. And the resulting vector u plus v in standard position does in fact end at 3 comma 10. In part B, numerically they want us to take the 3 and multiply by the vector u. So we're going to take u and make it 3 times as long. So I want 3 times -1 comma 3, which will result in the vector -3 comma 9. Visually what's happening is I start out with the vector u, -1 comma 3, and the resulting vector 3u is going the same direction, same slope, it's just got 3 times the magnitude. Part C, numerically we're going to take the scalar 2 and multiply by the vector u, and the scalar -1 and multiply by the vector v, which essentially means we are subtracting the vector v, which should result in the vector -6 comma -1. There's the vector u. Now twice as long, or twice the magnitude, would result in -2 comma 6. So there's the vector 2u. Now from there, I'm going to subtract the vector v. So instead of going right 4 and up 7, I'm going to go left 4 and down 7 from the head of the 2u vector. And then my resulting vector from the origin to my ending point will be 2u minus v, the vector -6, -1. Now try problem number 13. Asks us to add the vectors u and v together, which will result in the vector 1 comma 7. Now visually we'll take the vector u in standard form, and then we'll add 2 to the x-coordinate and 4 to the y-coordinate by putting the equivalent vector to vector v up at the head of vector u, which would then result in the vector u plus v, which is vector 1 comma 7, starting at the origin, ending at the point 1 comma 7.